Hi and welcome back to another LeetCode video. We're looking at another easy problem. We're looking at LeetCode 3550, smallest index with digit sum equal to index. I'm going to approach this not in the typical LeetCode style, but rather in a interview preparation kind of way where I follow the interview process. Even though it's a very simple problem, it's actually quite nice to use easy problems for that because it allows you to focus on the process that you would go through during an interview. And the process is understand the problem, check the constraints, check the examples, come up with a solution before writing code, possibly also give a runtime and space analysis before you write code, then implement your solution, test it, and then you're done. So let's do that. So we are given an integer array nums, right? So we receive an array of numbers. Return the smallest index I such that the sum of the digits of nums at position I is equal to I. Interesting. And if no such index exists, return -1. Constraints? Well, I would ask the interviewer, what is a nums? What are the values? What is the length, the minimum, the maximum length? Can it be nil? And the answer is that all numbers are positive. 0 is a positive number, so no negative numbers. And that we have at least one number in nums. Cool. Right, so I'm immediately thinking that we should just loop over the entire index, and at every index position, we check whether the sum of the digits is the same as the index. And we probably need a little helper function to implement the summing up of the digits. And and the whole thing can be done in linear time and with constant space. Now, if you were to be very precise, you could argue that summing up the digits is a log n operation, so technically it would be an n log n time, but we rarely ever do that. We just consider a numeric operation on numbers O of 1 for the most part. But in an interview, you can mention that, right? So O of n time and O of 1 space, and we're going to have a little helper function, and we're going to have a function that gives us back the sum of the digits, and we're going to implement that in a little bit. And just a tip in an interview, when you have the chance to break out part of the logic into a helper function, why not do it? It shows that you're able to compartmentalize the code, isolate functionality, and implement parts independently from each other. It makes the code a little bit less messy and makes it easier to follow you. So why not do it? So we're going to iterate now over nums, and with the index and the number itself in enumerate nums, right? And now we check if I is equal some digits of n, then we return the index, right? We should return the smallest index, yes, that's what we'll do. And otherwise, when we iterate through the whole thing and we don't find any index where the number at the index is the sum, the sum of the digits for that number at the index isn't I, we have to return -1. So, okay, cool. So now that part is finished, and now we have to implement our sum digits. Well, how do we do that? Well, how about we just iterate over all of the digits? And so we're going to have a little bit of sum here that we're going to compute, and we start with 0. And at the end, we're going to return the sum of those digits. And a nice way to do that without converting the number m into a string and then iterating over the digits in the string, what you can do, you just can do while m is not 0, right? You can get the next digit or the least significant digit by just taking m modulo 10 and then dividing m by 10, integer division. So what you do is when you have like a large number like this, let's take this. Basically, the first digit would be 2, and then we reduce m from 312 to 31. Next iteration of the loop, we pull out the 1 because we take our new m, 31 modulo 10, which is 1, and of our number gets divided by 10 again, and the rest gets thrown away, this line, and it's then 3. And in the final step, we get the digit 3, and m will be 0, meaning we have reached the end of the loop. And we've extracted all of the digits. So all we need to do is we need to update our sum with the digit. And or if we wanted to write it a little bit simpler, we just do it like so. Right. Okay, I think that is everything that we need. Let's run the test cases. Syntax error. There was a space too much. And by the way, double division sign means integer division. If we just did 1, that means we get a float division, and m would not be an int. But we want the integer division. Test cases pass. Nice. Now we're going to submit it to see if all of the test cases that LeetCode has prepared for us work. And it does, right. So that's the solution.